trig ratios for just a random angle, not within a triangle. So let's draw a graph. We're not just going to look at angles floating around in space. We're going to look at angles in standard position, which we talked about in 6.1. So the vertex of the angle must be on the origin. The initial side is on the x-axis pointing to the right. Zoom that. And the terminal side could be anywhere. We're going to put it, just for right now, for sake of ease, we're going to put it in the first quadrant. But this applies to angles in any quadrant. And we'll call this angle theta. Now, even though we aren't going to be using triangles in this lesson, we're going to make use of triangles for right now just to define the trig ratios for angles. What we first need to do, though, is find a point on the terminal side. So put a point right there. And let's call that point P, and its location is x comma y.
I got one of these problems on an ACT practice thing, and I guessed and I got it right.
Did you? That's good. I think doing a lot of trigonometry right before the ACT is going to help you guys. There seems to be a lot of trig on the ACT. So anyway, from that point, drop a line straight down to the x-axis. Again, we're going to use what we know about triangles to define some new trig ratio formulas. The distance from the origin to that point along the terminal side, we're going to call that distance r. And now what's the distance from here to here? X, exactly.
The other one y?
And the other one is y. How come? That's the point. The point is x comma y. X is a horizontal length, y is a vertical length. So we need to redefine now the sine of theta. Instead of using the terminology opposite over hypotenuse, let's use the terminology that we have on the triangle now. What's the sine of theta?
Y over x.
Not y over x, that's tangent.
Oh, y over r is.
Y over r. The sine of theta is y over r. The cosine of theta is x over r. And the tangent of theta is y over x. And we have to clarify something right here. X cannot be 0. We don't have to specify that for sine and cosine because r is never going to be 0. It's always going to have a positive value. Because the point is never going to be on the origin. So there is always going to be some distance between the origin and that point. So r is always some kind of a positive value. But x and y could be negative. Or I'm sorry, x and y could be 0. So in case x is 0, this tangent will be undefined. Now, the cosecant and the secant and the cotangent. Rather than referring back to this triangle here, let's just refer to the ones we've already defined. The cosecant is the reciprocal of the sine. So it's going to be r over y. Y cannot be 0. The secant is r over x, where x cannot equal 0. By the way, before I go any further, what kind of an angle would it look like where either x or y are 0? A straight line. What if we took this terminal side and, I don't want to erase that, but what if the terminal side were straight up along the y-axis? Then it would be a 90-degree angle, but what would the point along that terminal side be?
What if the y is?
It would be 0, comma y, so in that case, x would be 0. So the secant would be undefined, and the tangent would be undefined. We wouldn't be able to find the secant nor the tangent if the terminal side were on the y-axis. What kind of an angle would have a y value of 0?
A horizontal one?
Yeah. 180 degrees. Or it could be an angle of 0 degrees. So for those, you would have some of these that are undefined. Anyway, the cotangent is x over y, where y does not equal 0. Okay. And then let's quickly define r. R is the distance between the origin and that point. How do we find that distance though? Because we are going to have to know that distance. Yeah, r squared equals x squared plus y squared. It's just a Pythagorean theorem. So if you square root both sides, r is equal to the square root of x squared plus y squared. It's just Pythagorean theorem. So let's do a quick example. Suppose the point 3, 4 lies on the terminal side of angle theta. Find the 6 trig function ratios. You don't necessarily have to draw this out, but initially it might help. So if you have a graph, find the point 3, 4, and draw your angle such that the terminal side goes right through that point. Might help you to visualize. You could even draw a triangle if you want to. If you're more comfortable with triangles, you can draw one. Drop a line straight down from the point. Now we have a length of 3. We have a length of 4 there. The horizontal is 3. The vertical is 4. Hopefully, though, you're going to get to the point where you don't need to draw triangles for this, because you don't really need to. All you need to remember are these newly defined trig ratio formulas. Because x is 3. Y is 4. All you really need to do is find r.
You want us labeling the x and the equals 0?
No. R equals 5 because 3 squared is 9. 4 squared is 16. All that is a square root of 25. Yeah, it's a Pythagorean triple, 3, 4, 5. So once you know r, we already knew x and y. This could have been solved without drawing a triangle. To save time, it might help not to draw one. The sine of theta is just the y over r value. Y is 4, r is 5, so sine of theta is 4/5. Cosine of theta is x over r. The x value is 3. R is 5, so it's 3/5. Tangent is y over x, so it's 4/3. And then the cosecant's reciprocal of the sine, so it's 5/4. Secant is the reciprocal of the cosine, so it's 5/3. Cotangent would be 3/4. That's how a problem like that would work. We got to go into the second objective here. Evaluate trig functions at any angle. One of your problems on the quiz, it was problem 5. So this is the new objective. Evaluate trig functions The one I gave you on the quiz, I think, was the sine of pi thirds. All that was the sine of 60. So you had to refer to your 30, 60, 90 triangle, which we talked about last time. And the sine of 60 turned out to be the square root of 3 over 2. But that only worked if the angle was 30 degrees, 60 degrees, or 45 degrees. Only those three angles. We need to start evaluating trig functions at any angle, obtuse angles in particular, 120 degrees, or 180 degrees, or 310 degrees. So we first need to learn about what are called reference angles. And I believe many of you probably learned about this last year in Algebra 2. So let's draw an angle in the second quadrant. Here's theta. We don't have to know the exact measure for right now because it doesn't matter. Now from the terminal side, continue the angle. From the terminal side, draw another from the angle to the x-axis. That's what's called a reference angle. The notation this book uses is theta with a bar across it. Other textbooks use theta with an apostrophe. They both mean pretty much the same thing, reference angle. Okay. Let's define this here. Reference angle is an acute, meaning less than 90. Reference angles are always less than 90. An acute angle from the terminal side of the original angle theta to the x-axis, and I would underline the x-axis. Reference angles are never ever in relation to a y-axis, always in relation to an x-axis. Reference angles are always positive, and they're always less than 90 degrees. Real quick, before we do some actual examples, let's draw an angle in the third quadrant. So here's theta. It's some random angle in the third quadrant. How would we find the reference angle if it's in the third quadrant? We would have to go back. This gap right here, that's theta bar. Some students make the mistake of continuing that angle to the y-axis, but a reference angle is never drawn to the y-axis. It always must be drawn to an x-axis, and it's always positive. So it's not like we're going backwards and measuring clockwise. We're still measuring counterclockwise. If the angle happens to be in the fourth quadrant, whoa. So if we have an angle that's larger than 270 but smaller than 360, something in the fourth quadrant, then from here you just go from the end of the terminal side to that x-axis, and that would be theta bar.
Question, what angle can measure the
If it's a negative angle measure,
yeah.
then the reference angle would just be its equivalent positive angle measure. Like if the angle itself was negative 60 degrees, the reference angle would be 60 degrees. Reference angles are always positive. So here's how we use the reference angles. We're going to evaluate do the sine of 120 degrees. Evaluate the sine of 120 degrees. This means without a calculator. These all need to be done by hand. Problem is 120 degrees is not an angle within a special triangle, right? So we need to make use of reference angles. Yeah. So if we draw 120 degrees, that's about 120 degrees right there.
Do you not have tools for that?
I probably do, but don't have time for it right now. What's the reference angle? 60. So now if we made use of what we just barely talked about, this whole idea of y over r and x over r, if we imagine some point on the terminal side and made a triangle out of this, what kind of triangle is this? Now it's a 30, 60, 90 triangle. We have 30 degrees, we have 60 degrees, and we can label this similar to the 30, 60, 90 triangle that I drew earlier, but we have to be a little more careful because this point is negative x comma y because it's in the second quadrant, so we go over to the left and then up. So this actually is negative 1. Okay? This is the square root of 3, and that's positive 2. So what I'm trying to get at is the sine of 120 is equivalent to the sine of the reference angle, 60 degrees. We can do the sine of 60 degrees using this triangle here. What's it going to be? Square root of 3 over 2. The sine of 120 is equivalent to the sine of its reference angle, 60 degrees. The square root of 3 over 2. Now, what if I had asked, though, for cosine? We've got to pay attention to this. What if I had asked for the cosine of 120? We can still use this same picture, and we can still make use of the reference angle. The cosine of 60. Now, before we make use of this special triangle, let me go back up to the one I drew right here. If we were just using the normal special triangle, not drawn on a graph, what would the cosine of 60 be on this triangle here? It'd be 1 over 2. Okay, but we need to make use of this triangle specifically drawn in the second quadrant. What's the cosine of 60 in this triangle? It's negative 1 over 2. So the cosine of 120 is negative 1/2.
Isn't there like cosine is always negative?
Yeah, I'm going to talk about that in just a second. You're right, though. So when we make use of reference angles, we can use our special triangles, but sometimes the answer we give has to be negative. Sometimes the answer we give can be positive, and it depends on what quadrant you're in. Okay? Draw a blank graph with no angle on it at all. Write the word all in the first quadrant. If your angle is in the first quadrant, first of all, you don't even need reference angles because your angle is going to be larger or smaller than 90 anyway. So everything's positive in the first quadrant. Sine, cosine, tangent, cosecant, they're all positive. If your angle happens to be in the second quadrant and you use reference angles, do you notice the sine of 120 was exactly the same as the sine of 60? So the sine is positive in the second quadrant. Even if you use reference angles, the sine is still positive, but everything else is negative, with the exception of cosecant, because cosecant is related to the sine. So the sine and the cosecant are positive in the second quadrant. If your angle happens to be in the third quadrant and you make use of reference angles, the tangent is positive, and because of that also the cotangent, but everything else is negative. And if you're in the fourth quadrant, the cosine is positive, and also the secant would be positive. We're going to get into the unit circle in chapter 5, but yeah, this has to do with the unit circle. Now, there's a little mnemonic, I think, that some of you might remember to help you keep track of what's positive where. If you just take the first letter, of each of those, all students take, do you not remember this? Calculus. All students take calculus. That might help you remember what goes where. Somebody the other day came up with a new one in one of my Algebra 2 classes. All seminary teachers care. But no, it's all students take calculus. Let's try a new example here. Or it's not example 2. Where are we? Example 3? No, it is example 2. Example 2. Evaluate the cosine of 210 degrees. Now let's try to get to the point where we can do this without drawing the angle and making a triangle out of it. Where is 210 degrees? Third quadrant. Okay. What would the reference angle be? If 180 degrees and then you've gone 210, how far beyond 180 are you? You're 30 degrees beyond 180. So the reference angle is 30 degrees. So we're going to refer to the cosine of 30 degrees instead of the cosine of 210. 30 degrees is the reference angle for 210. So now we need to make use of our triangle, the 30, 60, 90. 60 degrees, 30 degrees. Normally, the cosine of 30 degrees is the square root of 3 over 2. That's the cosine of 30 degrees. Now, is that the answer for the cosine of 210 degrees?
No.
It's just negative square root of 3. Why do we have to make it negative? Because we're in the third quadrant, and only tangent's positive. Everything else is negative in the third quadrant. So the answer is negative square root of 3 over 2. If I ask you for part B to evaluate the sine of 7 pi fourths, most students probably would. The more comfortable you get with radians and fractions, you might not have to. But initially, it's okay. Don't feel bad if you change into degrees. It's normal. But I'm just saying you don't have to. But what is 7 pi fourths in degrees? The reference angle is 45. But 7 pi fourths is 315. So we can now take a look at the sine of 315. 315 is the same as 7 pi fourths. Now 315 is in the fourth quadrant. All the way back up to the x-axis is 360. So what's the gap between 315 and 360? 45. So the reference angle, is 45 degrees. So we're no longer going to try to evaluate the sine of 315. We're going to evaluate the sine of 45. 45 is one of our special triangles. It's the 45, 45, 90, where the side lengths are 1, 1, and the square root of 2. So if we're trying to find the sine of 45, it's opposite of hypotenuse. So it's 1 over the square root of 2, which is the square root of 2 over 2. But because we're in the fourth quadrant, what's positive in the fourth quadrant? Only cosine. We're doing sine. Or secant. So this has to be, the answer to the original problem is related to this. We just have to make it negative. So the answer is negative square root of 2 over 2.
Have you ever found one that's like already negative, but is now positive because it's in?
Let's take a look at part C. Let's do the cosine. Negative 5 pi thirds. Cosine of negative 5 pi thirds. So what is negative 5 pi thirds? It's negative 300. Cosine of negative 300. But negative 300, if you're going clockwise, negative 300 puts you in the first quadrant. The reference angle would be 60 degrees. So we can now look at the cosine of 60 degrees. Because we're in the first quadrant, any answer would be positive. Cosine, sine, tangent. Cosine of 60 is 1/2. 1/2. So the answer to the original problem is 1/2.
So pretty much the reference angle is just
Yep. Here are some critical thinking examples. Example 3. Find the quadrant. It's just making use of this right here. All students take calculus. Find the quadrant in which theta lies. So for part A, if the tangent of theta is negative, meaning less than 0, and the sine of theta is negative. If the tangent of theta is negative and the sine of theta is negative, where would theta be? In the fourth quadrant. Why can't theta be in the first quadrant?
because all of them are positive.
All of them are positive in the first quadrant. It can't be in the second quadrant because their sine would be positive. It can't be in the third quadrant because their tangent would be positive. So this has to be theta is in quadrant 4. So there's one or two problems I assigned that just kind of make you think about where theta is. And there's one or two like this. Example 4. We're not going to have time for objective 3. Where's objective 3? Basic trig identities or area. We're going to have to save that for next time. But example 4. Find the values of the trig ratios. Rather than giving you the diagram of a triangle or the diagram of an angle, I would tell you something like the cosine of theta is equal to negative 7/12, and theta is in quadrant 3. So the cosine of theta is negative 7/12, and theta is in quadrant. Why do we need to know where theta is? So we know it's positive and negative. Because it's in quadrant 3, the tangent and the cotangent can be positive, but the sine and cosecant can be negative. So we already know cosine. That means we need to find the sine of theta. We need to find the tangent of theta. We need to find the cosecant of theta. Do we know what the secant is?
Yeah. So it's 12 over negative 7. Or I guess negative 12.
Yeah, it's just the reciprocal of the cosine. So we already know the secant, and then we need to find the cotangent. Now we need, again, we're going to make use of these new definitions. Instead of doing opposite and hypotenuse and adjacent and hypotenuse, this is an x value, and that's an r value. How do I know that? That's the definition of cosine. Cosine is x over r. So if we know x and we know r, what do we need to find to fill in the rest of this? We need to find y. Exactly. We need to use the formula r equals the square root of x squared plus y squared. And we need to manipulate in this in such a way that we can find the value of y. So 12 is equal to the square root of what? Negative 7 squared, which is 49 plus y squared. If you square both sides, you're going to get 144 is equal to 49 plus y squared. If you subtract 49 from 144, you get, let's see, 144 minus 49, 95. So y squared equals 95. Now we got to think here for a second. What quadrant are we in? We're in the third quadrant. Is y positive or is y negative in the third quadrant? It's negative. Technically, when you take a square root, you can choose between a positive or a negative because you have that plus or minus sign in front, right? Which one are we going to choose here? Negative. It's negative square root of 95. And then we got to think, all right, is there anything that divides into 95 that has a square root? We know 5 divides into it because it ends in 5. But 9 doesn't divide into it. 16 doesn't divide into it. 25 doesn't divide into it. Neither does 36. So that doesn't simplify. So y is equal to negative square root of 95. The definition of sine is y over r. So it's negative square root of 95 over 12. What's the definition of tangent? That's for the triangle. What was it for generally? Y over x. So it's going to be, initially it's negative square root of 95, but then you divide that by negative 7. And that's why it comes out positive. So it's the square root of 95 over 7. The tangent's positive because it's in the third quadrant.
So 7 is
Yep. Now the cosecant is just the reciprocal of the sine, so it's going to be negative 12 over the square root of 95, which is negative 12 square roots of 95 over 95. Holy crap, bell's ringing. Cotangent is 7 over square root of 95, which is 7 square roots of 95. What the? Where's the bell? Doesn't that say 910? Oh, weird. Over 95. So we'll have to finish this up. Well, actually,